We'll start in a couple of minutes. All right, 8 o'clock. We're in section 6.3 again, but the second part has some more factoring special products. Okay, we'll review these facts here. Factoring is the reverse process of multiplying. And you can check your factoring by multiplying. And the first step in factoring is to factor out the greatest common factor of all terms. Today we'll look at a sum of cubes. That means that you're adding two things that are raised to the third power. A sum of cubes has the following form: a to the third plus b to the third. So the word sum, S-U-M, refers to addition. And a sum of cubes has a binomial factor and a trinomial factor. So if you see something that has the form a to the third plus b to the third, the binomial factor is a plus b, and the trinomial factor is a to the second minus ab plus b to the second. In general, if the greatest common factor of a to the third and b to the third is 1, then it will turn out that the trinomial cannot be factored with integer coefficients. So in a case like this, if the greatest common factor of the two terms a to the third and b to the third is 1, then the complete factorization is a plus b times a to the second minus ab plus b to the second, if you're only factoring over real numbers. Okay, we can verify that a plus b times a to the second minus ab plus b to the second is equal to a to the third plus b to the third if we multiply. So let's verify this by multiplying. So first we multiply a times every term in the trinomial. A times a to the second is a to the third, and then minus a times AB is minus a to the second B. Then we multiply B times, sorry, have one more step. A times B to the second is plus A times B to the second. Okay, then we multiply B times every term in the trinomial. So B times A to the second is the same as adding A to the second B. And then we multiply B times negative AB, which is minus AB to the second. And then finally, B times B to the second is plus B to the third. And then when you combine like terms, there's one A to the third term. And the terms in this column add up to 0. We have negative A to the second B plus A to the second B. So we just get 0 there. And then in the next column, A times B to the second plus A times B to the second, A times B to the second plus negative A times B to the second also adds up to 0. And then there's one B to the third term. So the product is the sum of cubes, A to the third plus B to the third. Okay, we also have what is called a difference of cubes. Difference implies subtraction. Okay, so a difference of cubes has the following form. A to the third minus B to the third. And a difference of cubes has a binomial factor and a trinomial factor. The factorization of A to the third minus B to the third, the binomial factor is A minus B, and the trinomial factor is A to the second plus AB plus B to the second. If you look closely at the factoring formula for a sum of cubes and compare it with the factoring formula for a difference of cubes, you'll be able to note some similarities in those two formulas. Okay, but let's go ahead and verify that the product of A minus B and A to the second plus AB plus B to the second is equal to the difference of cubes, A to the third minus B to the third. So we can check our factoring by multiplying. So we multiply A times every term in the trinomial. A times A to the second is A to the third. And then plus A times AB is plus A to the second B. And then plus A times B to the second is plus A times B to the second. Then we multiply negative B times every term in the trinomial. Negative B times A to the second, that's equivalent to subtracting A to the second times B. And then negative B times AB, that's equivalent to subtracting A times B to the second. And then negative B times B to the second is minus B to the third. And then combine like terms, we have one A to the third term. The terms in this column add up to 0. The terms in this column add up to 0. And then there's a minus B to the third. So when we simplify, we get a difference of cubes, A to the third minus B to the third. Okay, one thing that you probably already noticed, when we factor a sum of cubes, A to the third plus B to the third, the binomial also has addition A plus B. And corresponding to that, in the difference of cubes, A to the third minus B to the third, the binomial factor also has subtraction, A minus B, as one of the factors. So noticing things like that can help you remember those formulas. Okay, we'll look at some examples. Well, arithmetic, having a more thorough understanding of arithmetic helps when factoring in general. So if you're looking at a sum of cubes, it's helpful to know that you are looking at a sum of cubes. That's what we're looking at here, 27m to the third plus 64n to the third. We can rewrite 27m to the third as the term 3m in parentheses to the third. So 3 times 3 times 3 is 27, and m times n is m to the third. 64n to the third is also a perfect cube. 64 is 4 to the third and n to the third. That's the more obvious one. But if we raise the term 4n to the third, we get 64n to the third. So we're factoring a sum of cubes. So if you remember, I can write the formula up here to remind you, a to the third plus b to the third. The binomial factor is a plus b. The trinomial factor is a to the second minus ab plus b to the second. One way to help memorize formulas is by writing them down. Try to write them down from memory and do it a lot of times. Repetition will help you remember it, but also focus on what you're doing when you're trying to recite it by writing it down. Okay, so we have a sum of cubes. The term that takes the place of a is 3m, because we have the term 3m to the third. The term that takes the place of b is 4n. So a plus b for this one is 3m plus 4n. And then in the trinomial, a to the second, well, we're going to square the term 3m. So we get 9m to the second. And then we're going to subtract ab. So this time we're going to subtract 3m times 4n, or minus 12mn. And then we're going to add what we get when we square 4n. The term 4n squared is 16n to the second. Okay, so that is our factorization for that sum of cubes. The one on the right is a difference of cubes. We refer to 8 as a perfect cube because the number 2 raised to the third power is equal to 8. So we can rewrite it so that it is more evidently a difference of cubes. If you raise the term 2x to the third, you get 8x to the third, and then minus y to the third. Okay, the binomial factor then is 2x minus y. And then the trinomial, the first term in the trinomial is what we get when we square the term 2x. When you square the term 2x, 2x times 2x is 4x to the second. Then we're going to add 2x times y. which is 2xy. And then finally, we're going to add y to the second. And so the difference of cubes factoring formula, a to the third minus b to the third, is a minus b times a to the second plus ab plus b to the second. Well, I should have noted, but I didn't because it was of no consequence, but the greatest common factor of these two terms is 1. So we didn't need to factor anything out. And the same, in this case, the greatest common factor of the two terms is 1. Okay, but in the next example, the greatest common factor isn't 1, it's something else. Okay, so both terms have n, so we can at least factor n out. And 343 is 7 times 7 times 7, or 7 to the third. 125 is 5 times 5 times 5, or 5 to the third. So the greatest common factor is just n. So we factor that out first. And then in parentheses, we have 343 plus 125t to the third. Inside the parentheses, we have a sum of cubes. So we'll look at that in isolation, the 343 plus 125t to the third. So 343 is 7 to the third, and 125t to the third is equivalent to raising the term 5t to the third. So we have a sum of cubes. The binomial factor is 7 plus 5t. And then the trinomial, the first term in the trinomial is 7 to the second. I'll go ahead and write 7 to the second. We'll simplify it more in the next step. Then we're going to subtract 7 times 5t, 7 times 5t. And then we're going to add what we get when we square the term 5t. Okay, so we'll rewrite this as 7 plus 5t, and then simplify the terms in the trinomial. 7 to the second is 49, and then minus 7 times 5t is minus 35t, and then plus 25t to the second. Okay, remember that we started with this polynomial, so we have to, in the final factorization, we have to include the factor n. So I'll squeeze that in up here. That's equal to n, and then the factorization of the sum of cubes. So n times 7 plus 5t times 49 minus 35t plus 25t to the second. So this is the complete factorization. Okay, the next one, 135b to the third y plus 320a to the third y. The greatest common factor isn't 1, so we have to find the greatest common factor and factor that out. So what do you think the greatest common factor is? Well, if we look at the numerical coefficients, 135 and 320, we know that 5 goes into each of those. 5 goes into 135 27 times, and 5 goes into 320 64 times. And 27, the greatest common factor of 27 and 64 is 1. So for the numerical factors, 135 and 320, the greatest common, that's right, greatest common factor is 5. Then we compare the variable parts. Each of the terms has one factor of y. So 5y is the greatest common factor. We want to factor that out first. So when we factor 5y out, we get 5y times 27b to the third plus 64a to the third. Uh, 27b to the third plus 64a to the third is a sum of cubes. So let's look at that down here in isolation. 27b to the third plus 64a to the third. I didn't really need those parentheses there, but you can think of this as the term 3b to the third, and then 64a to the third is equivalent to raising the term 4a to the third. And then apply the sum of cubes factoring formula. The binomial is 3b plus 4a then in the trinomial, the first term is what we get when we square 3b. I'll write it in a little more detail. It's not absolutely necessary, but maybe it will help when we're starting out. So we're going to square the term 3b, then we're going to subtract 3b times 4a, and then we're going to add what we get when we square 4a. And then in the next step, 3b plus 4a. And then the trinomial, when we square 3b, we get 9b to the second. And then when we subtract 3b times 4a, that's the same as subtracting 12ab. And when we square 4a, we get plus 16a to the second. All right, so up here, when we write the complete factorization of this original polynomial, we have to include 5y. So 5y is a factor, and then we'll write this factorization. 3b plus 4a times the trinomial 9b to the second minus 12ab plus 16a to the second. Okay, another one. 125w to the third x minus 729v to the third x. Well, each of the terms has x, so we can factor that out at least. So for the variable parts, that's the only variable part that's a common factor to both. What about the numerical factors, 125 and 729? What's the greatest common factor of those two numbers?
Would it be 1?
How much?
Just 1?
Yeah, it's just 1. Yeah, 125 is 5 to the third. 125 is a perfect cube, 5 to the third. 729 is 9 to the third. So 729 is a perfect cube. Okay, so first we factor x out. And when we factor x out, we're left with a difference of cubes inside the parentheses. So let's look at that by itself. 125w to the third minus 729v to the third. We can rewrite 125w to the third as the term 5w to the third. This just means 5w times 5w times 5w. And we can replace the minus 729v to the third with minus the term 9v to the third. Then apply the difference of cubes factoring formula. The binomial is 5w minus 9v. The first term in the trinomial is what we get when we square the term 5w. 5w times 5w is 25w to the second. And then we add 5w times 9v, which is plus 45wv. And then we add 9v squared, which is 81v to the second. So our complete factorization has to include x. So we rewrite that as x times this factorization, 5w minus 9v, and then the trinomial, 25w to the second, plus 45wv, plus 81v to the second. Okay, let's move on to the next page. The first one, 216t to the third minus 27r to the third. The greatest common factor is 1. 216 is 6 to the third. 27 is 3 to the third. So what we have is a difference of cubes. So we can rewrite it as the term 6t to the third minus 3r to the third. And then apply the difference of cubes factoring formula. The binomial is 6t minus 3r. And the trinomial, the first term in the trinomial, 6t, the term 6t squared is 36t to the second. And then we're going to add 6t times 3r, which is 18tr. And then we're going to add what we get when we square 3r. 3r times 3r is 9r to the second. So is that the complete factorization? Well, no, because it is true that this is a difference of cubes, but the greatest common factor is not 1. So what is the greatest common factor? How much?
Would it be 3 or would it be 9?
2? Well, it's more than 3. 3 is a common factor.
9? I think you said.
9 is a common factor. Is 9 the largest?
Oh, 27.
Yeah, how many times will 27 go into 216?
8.
How many?
8.
Yeah, 27 goes into 216 8 times. So 27 is the greatest common factor. So we could find the complete factorization from this, but if we do it by the book from the start, we first factor 27 out, and 27 times 8t to the third minus r to the third is the way we should have perhaps started. But inside the parentheses, we have a difference of cubes because 8 is a perfect cube. So we can rewrite this as 27, and then in parentheses, the term 2t to the third minus r to the third. And so the complete factorization is going to be 27, and then the binomial 2t minus r. And the trinomial, when we square 2t, we get 4t to the second. And then plus 2t times r is plus 2tr, and then plus r to the second. Okay, so this is the complete factorization. I did mention that we could, from this stage, get the complete factorization. The greatest common factor of 6t and 3r is 3, so we could write this as 3 times 2t minus r. And then out of 36t to the second plus 18tr plus 9r to the second. 9 is the greatest common factor, so we could factor 9 out of each of those 3 terms. When we factor 9 out of 36t squared, we get 4t to the second. And then factor 9 out of 18 TR, we get plus 2 TR. And factor 9 out of 9R to the second, we're left with R to the second. And then when you multiply the numerical factors, 3 times 9, we get 27, and then the binomial 2t minus r, and then the trinomial 4t to the second plus 2tr plus r to the second. So watch out for those, even though what we started with is a difference of cubes, we still have to write the complete factorization. So it will probably be easier to recognize what the greatest common factor is to start with. Okay, the next example. So this looks like a mess. 250 times x times y times u to the third times v to the third plus 686 times x to the fourth times y to the fourth. Okay, let's see if we can find the greatest common factor when comparing the numerical factors, 250 and 686. They're both even, so 2 goes into both of those numbers at least. 2 is a factor. 2 times 125 is 250. 2 times 343 is 686. Well, 2 times 125, the factors of 125 are 5 times 5 times 5. And then 2 times 343, the factors of 343 are 7 times 7 times 7. So 2 is the greatest numerical factor. Each of the terms has a factor of x. And each of the terms has a factor of y. So we can factor 2xy out. And then we're going to be left with 125 u to the third, v to the third, plus 343 x to the third, y to the third. Okay, so this, inside the parentheses, is a sum of cubes. So let's write 2xy, and then instead of 125 u to the third, v to the third, we'll write that as the term 5 times u times v to the third. And then we will replace 343x to the third, y to the third with, in parentheses, 7 times x times y to the third. And we can see that we have a sum of cubes. So we can apply the sum of cubes factoring formula. The binomial is 5uv plus 7xy. And then the trinomial, the first term is what we get when we square the term 5uv. So that will be 25u to the second, v to the second. Then we're going to subtract 5uv times 7xy, which is minus 35uvxy. And then we're going to add what we get when we square the term 7xy, which will be 49x to the second, y to the second. Hey, that's the complete factorization. So when you see the more complicated ones, make sure you do them, make sure you try them, that will just make you better at factoring. If you avoid the hard ones, then you're not going to develop the way that you should. Hey, the next one, x to the sixth minus 64. So what are we looking at? Well, we can say that that is a difference of cubes. Because if you raise the term x to the second to the third power, remember the properties of exponents, x to the second to the third is equal to x to the 3 times 2, or x to the sixth. And 64 is 4 to the third. Okay, so it is a difference of cubes. But it's also the case that it can be interpreted as a difference of squares. X to the sixth minus 64. See, what would you have to square to get x to the sixth?
X to the third.
Yeah, you would have to square x to the third. And then 64 is 8 squared. So it's also can be interpreted as a difference of squares. And I'll remind you of the difference of squares factoring formula that we talked about before. A to the second minus b to the second is a minus b times a plus b. Well, it turns out that we can get to the complete factorization either way. So we'll do it one at a time. First, if we interpret this as a difference of cubes, we'll just apply the difference of cubes factoring formula. So our first term will be x to the second minus 4. And then in the trinomial, we're squaring x to the second, so we get x to the fourth. Then we're adding 4x to the second. And then we're adding 16. But notice over here, x to the second minus 4, that is a difference of squares, so that has to be factored. So x squared minus 4, the factors are x minus 2 and x plus 2. And then x to the fourth plus 4x to the second plus 16. So let's go work on this one. If we first interpret it as a difference of squares, something squared minus something else squared, we'll get x to the third minus 8 times x to the third plus 8. What are we looking at now? We're looking at a difference of cubes and a sum of cubes. So, because 8 is 2 to the third. So let's factor the difference of cubes, x to the third minus 2 to the third. We get x minus 2 times x squared plus 2x plus 4 And then when we factor the sum of cubes, x to the third plus 2 to the third, we get a x plus 2. And then the trinomial is x to the second minus 2x plus 4. So which one do we regard as the complete factorization? Well, we have more factors on the right than we do over here. So this implies, if I didn't make any mistakes, this implies that if I multiply x to the second plus 2x plus 4 by x to the second minus 2x plus 4, I should get x to the fourth plus 4x to the second plus 16. So let's verify that. Let's multiply x to the second plus 2x plus 4 times x to the second minus 2x plus 4. So we multiply the two trinomials. We need to practice multiplying trinomials. So x squared, we'll multiply x squared times everything in this trinomial first. So x squared times x squared is x to the fourth, and then minus 2x to the third, and then plus 4x to the second. And then we multiply 2x times the trinomial. 2x times x squared is plus 2x to the third, and then minus 4x to the second, and plus 8x. And then multiply 4 times the trinomial. We get plus 4x to the second, minus 8x plus 16. Then we add all of those. We have 1x to the fourth term. The minus 2x to the third plus 2x to the third, that adds up to 0. 4x squared minus 4x squared plus 4x squared is plus 4x squared. Plus 8x minus 8x is 0, and then plus 16. Then we simplify a little bit. We get x to the fourth plus 4x to the second plus 16. So yeah, it works out. So if we interpret this as a difference of cubes, it might not be obvious to us that x to the fourth plus 4x squared plus 16 can still be factored to x squared plus 2x plus 4 times x squared minus 2x plus 4. So don't worry too much about this. This is more of a little bit of an extracurricular problem. But either way, you should be able to factor it as a difference of cubes or a difference of squares. Okay, we'll look at some review problems. So we'll just work on some problems until it's time to quit. Factor the following: 4a to the second plus 28a plus 49. The greatest common factor of all three terms is 1. Notice the first term on the left is a perfect square. If you square the term 2a, you get 4a to the second. 49 is also a perfect square because 7 to the second is 49. So maybe you're wondering if it's a perfect square trinomial. So if it is a perfect square trinomial with two plus signs, it will have this form: a to the second plus 2ab plus b to the second. And if it is a perfect square trinomial, the two factors are the same, a plus b times a plus b. So we'll think of the 4a to the second as the term 2a to the second. And the term on the right, 49, think of that as 7 to the second. And we want to see if the middle term, plus 28a, has the proper form, plus 2ab. So we'll write down plus 2 times 2a times 7, and then do the arithmetic. And we note that 2 times 2 times a times 7 is plus 28a. So yes, it is a perfect square trinomial. So its two factors are 2 times capital A plus 7 times 2 times a plus 7. Okay, the next one, 36b to the second minus 60b plus 25. The greatest common factor is 1. The term on the left is a perfect square. This is 36b to the second is the same as squaring the term 6b. And the term on the right, 25, is a perfect square, 5 to the second. So you might wonder if it's a perfect square trinomial. So if it is a perfect square trinomial, it has this form, a to the second minus 2ab plus b to the second. And then the factors are identical, a minus b times a minus b. So we can verify if that's a perfect square trinomial if the middle term has the right form, if it has the minus 2ab. So we write minus 2 times 6b times 5, and then do the arithmetic. 2 times 6b is 12b, 12b times 5 is 60b. So minus 60b matches the trinomial above. So it is a perfect square trinomial. What are the two factors? 6b minus 5 and 6b minus 5. Okay, we're out of time for today. So keep practicing the factoring problems, and we'll do some more tomorrow.